Scope ships with some incredible built-in pipelines, but the thing that makes Scope really powerful is what you can add on top of it. And just recently, Scope has gotten a plugin system. It is a proper, well-designed architecture where you can build your own pipelines, your own preprocessors, your own post-processors, and plug them into workflows and control them with live UI parameters. That is what I want to show you today. I built a visual effects plugin to demonstrate how this works, and by the end of the video, you will know how to build your own. So here's what I built. It's called VFX Pack. It has two effects. So it's chromatic aberration that I can turn on and off, and there is also VHS retro CRT effect that I can as well turn on and off. I can even combine them, stack them, and play around with the different parameters, as you can see. So every parameter you see here has a live slider. I defined these in a Python schema, and Scope automatically rendered the UI for me. I didn't even have to write a single UI line of code for me. The toggle effects, as I said, you can turn them on and off, and everything updates on the next frame. But now here is where the plugin system really shines. I will now switch the main pipeline to LongLive. LongLive is one of the generative AI video models that we are supporting. And I have already selected VFX Pack as my post-processor. So basically my plugin will run on top of whatever the LongLive is now going to generate. Let's give it a second. Oh, there you go. So now Scope is generating Panda based on this prompt that we have here in real time, and my plugin is applying effects on top of the AI output. So it's the same plugin with the same code. It just slots into a different position in the chain. So think about for a second what this means. This means that you could build a color grading plugin, a custom preprocessor that maybe feeds specific input into a model, an upscaler, or even a custom model integration. And all this is just a hint of things to come and what's possible. So let me show you how to build it from scratch, and by the end, you'll have everything you need to start building your own plugins. So now I'm in my VS Code, and your plugin is nothing more than just a Python package with an entry point, and Scope discovers it, loads it, and integrates it into the UI automatically. A plugin registers one or more pipelines, and a pipeline essentially is a class that's processing your frames. That's the contract, right? So Scope handles everything else: discovery, installation, UI rendering, as you've seen it before. And the pipeline chain looks like this. Input goes to a preprocessor, then the main pipeline, usually an AI model like we've seen in the previous example with LongLive, and then a post-processor followed by an output, right? So your plugin can sit in any of these slots, and switching between them is mostly just like a single metadata tag. So let's start from the scratch and explore the current directory structure. Here is what we have here. It is a pretty standard Python package layout. So plugin entry point in initpy that I can open here, configuration schema in schema.py, pipeline logic in pipeline.py, and each effect actually has its own file under the effects folder, chromatic.py and VHS file. Let's explore the Py project toml. As you can see, it is pretty minimal, and the important part here is the entry point declaration, this part here. So this is how Scope discovers your plugin. It scans all installed packages for entry points in the Scope group and loads whatever module they point to. It's just, as I said earlier, a standard Python entry point. And notice that we currently don't have any major dependencies here. Scope Environments already has PyTorch, and that's pretty much everything that I needed for this plugin. And you can add dependencies if you're pulling in something that Scope doesn't already provide. So that is pretty much how this currently works. Okay, now we are in initpy. This is your entire plugin registration. It just has several lines of code. The hook implementation decorator comes from Pluggy, which is the plugin framework that Scope uses. And when Scope loads your package, it calls this register pipelines function, giving you a callback. You call it once for each pipeline class that you want to register. Notice one thing, however, that the import is inside the function body, and that's deliberate, that's on purpose. It delays loading PyTorch and all your heavy pipeline code until Scope actually needs it. It basically keeps the startup fast. Now let's switch to schema.py. This is where things actually get quite interesting. And the schema defines two things. It defines metadata about your pipeline, and the parameters that show up in the UI. So you can see here we have pipeline ID, there is a pipeline name, pipeline description. All these, tell Scope how to display your pipeline. Supports prompts, I currently set it up as false, basically hides the text prompt input since, in this case we are not using it. And the modes equal video also tells our pipelines that it will need a video input. You will remember when I started this video, there was this cat that I was using it as a video input for myself. And then each field basically becomes a UI control. A booleans basically turn into toggle switches, a floats or integers with constraints also become sliders. And for example, if you were to have some enumeration, it would become a dropdown. The other thing that I would like to bring your attention to is this part here, UI field config. It basically sets the display order and the labels. So for my chromatic aberration plugin here, I have the order 1, 2, 3, and so on. And for the VHS one, I have 10, 11, 12, and going forward. That basically leaves me room to add more effects in between later without having to renumber everything. And one important thing, and this is pretty crucial, and I think that you actually observe it when I was showing the initial demo, all of these are runtime parameters by default, meaning that they update live while streaming. If you move a slider, you see a change in the next frame. If you needed something that requires a restart, like maybe a model selector, you would add isLoadParam equals true. So now let's move and explore our effects files. So I will start with our chromatic.py. So first effect, chromatic aberration. So the idea here is very simple. So you take the red and blue color channels and shift them in opposite directions. So green stays where it is. This mimics the optical imperfection in real camera lenses where different wavelengths of light bend differently. And having a torch.roll here actually does all the work, right? It shifts a tensor along the dimension, wrapping pixels from one edge to another. And since it operates on GPU tensors, it runs in probably microseconds, even at high resolutions. And you can also see that we have intensity parameter mapping from 0 to 20 pixel displacement range. At the default of 0.3, that's about 6 pixels of a shift. It is noticeable, but not overwhelming, and angle actually rotates the displacement direction. That's the whole effect, and as I said, torch.roll makes this super cheap on GPU. That's why we are not running this on CPUs, otherwise it would be very slow. Now let's check our VHS retro effects. This one is a little bit more involved. It is actually 3 sub-effects stacked together. So the first one is scan lines. We create a sine wave across the frame height and then use it as a brightness mask. So that gives you that appearance of alternating dark bands like a CRT monitor. The scan line count controls how many lines, scan line intensity controls how dark they are. Second, there is this analog noise which adds this film grain. It's basically just a Gaussian noise added to a frame. I keep the multiplier low, noise times 0.15, so even when you crank it up to the max, it does not completely destroy the image. And last, and this is a fun one, tracking distortion. So each row of pixels shifts horizontally by a different amount, giving that like a sine curve. And that creates that classic wobbly VHS look. And one thing that I want to draw your attention here, now you might think that you'd want to do this per row loop, and that would work, but it would be incredibly slow. So instead of that, what we are doing, we are using grid sample. So we wrap the whole frame in one GPU up instead of looping row by row. And finally, let's check pipeline.py file. This is the pipeline class that ties everything together. It has 4 methods. Most of them are short. So the first one is, let's go here and find them. So first one is getConfig class. So basically returns our schema. That's how Scope knows exactly which parameters belong to this pipeline. The other one, the init one, is basically just grabbing the device. The keyword arguments catch all here is important because Scope may pass extra stuff that we don't care about. Then there is also prepare, telling Scope how many input frames to buffer before calling us. We actually need just 1 frame here for our needs. Since our effects, they don't have really some temporal dependencies, we are doing them just on that single frame. And lastly, there is call. This is where all of it happens, right? So we get the video frames from keyword arguments, stack and normalize them, run each enabled effect in sequence, and then return the result. If we would to stash our runtime parameters in the init, they wouldn't update live. So all this was pretty technical, but how it actually looks like when we go back to scope. So again, I here have my pipeline and my effects running, but I've actually stored my repository on a GitHub. And when you go to settings, go to plugins, there are a couple of ways for you how to get and install plugin and run it in scope. You can either go by installing it with the PyPI package, you can paste your GitHub URL here, or you can even use your local path. Depends on your development use cases, or depends how you work. So currently, as I said, I just used my GitHub, pasted it earlier here, and my plugin actually showed up and appeared here. Now let me switch back to another pipeline. So basically I want to use VFX-Pack as a pipeline itself. I don't even need a post processor here. I hit play, and you'll remember the things that we just covered earlier, right? So for our chromatic aberration, for our VHS retro CRT, all of those controls are available and exposed to me in my settings panel. So everything we defined in the schema, it's rendered automatically. Toggle VHS on and off. If I toggle it on and let's say this one off, add some scan lines, maybe decrease or increase their intensity, you can see everything happening in the real time. And we're developing the workflow is the following, right? So you edit your code, you commit it or save it, and depending on your installation way, Scope picks up your changes, restarts the server in background, and you're good to go. Now the next reasonable question is, how do I add my own effects? So the process is actually simple. I'll jump back into my VS Code again. As you can see here under the effects, I have Chromatic Pi and VHS Pi, as I said before. So the architecture is designed so that adding a new effect is always the same 4 steps. So 1, you create a new file in effects. You write a function taking the tensor and returning a tensor. 2, you add parameters to schema.py. Just so it's aware, with the toggles and whatever knobs you might want and need. 3, you wire it in the effect chain in the pipeline.py. The same process that we had before. Check it's enabled, call the function with the current slider values. And lastly, in effects, in the py, you just export it and make it visible. So once you make those changes, you either save locally or make your commits, and the scope will reload and new effects will show up in the UI. So it's the same pattern every way. And now once you've done that, you can reload, you can do a new commit, and the scope will recognize the changes in your plugin, and the new effect will show up in the UI. It's pretty much the same pattern every time. The plugin grows, but the architecture stays simple. So to really quickly recap, we built a GPU accelerated visual effects plugin for scope in less than 200 lines, I think. 2 effects, I believe 8 live parameters, working both as a standalone pipeline but also as a post-processor for AI models. We saw it applied on the long live output. And the plugin system itself, again, really well designed. You can just easily define a schema, Scope will render the UI for you, you write a function transforming tensors, and Scope handles streaming and everything else. You set the metadata field, Scope puts you in the right spot for the pipeline chain. Most of the complexity is actually handled for you. All the source code for this plugin is on GitHub, link is in the description. And if you want to build your own Scope plugin, you can follow also our tutorials in Scope docs. And in the follow-up video, I will show you how you can build your plugins using AI-assisted development. Now, go on and build something awesome.